Hi guys, so today we are going to do Module 4, Lesson 8 and 9. And one thing that we need for our lesson is our 3D shapes that we created using our nets in our notebook on paper. Okay, you should have done this yesterday or Wednesday, and they will be helpful tools for you to use when we're going through this lesson. Okay, if you don't have them or they're not perfect, or you maybe got frustrated while you were trying to put them together, that's okay because we can use my shapes as we go through our lesson. Okay, but these will just help you if you have them handy. Okay, so we are going to look at this slide real fast because this slide tells us our objective for lesson 8 and 9 in Module 4. So the point of this lesson is to identify, describe, compare, and contrast solid figures according to their characteristics. So we're going to look at solid figures, solid geometric figures, and we're specifically looking at these these 6 figures, and those are the ones that you should have put together using your diagrams in your workbook. Okay, so we are going to identify different characteristics first about these figures. Okay, so there are different things that we're going to look at. So we're going to start with this cube. This is a cube. So your cube looks like this. Okay, look at the faces of this cube. A face of a solid figure is any flat surface. Okay, a flat surface, because we'll look at some figures that don't have flat surfaces. So any flat surface is called a face. Okay, so I'm going to write that down, a face. Okay, face is any flat surface. So I want you to look at the faces of this cube and tell me what you notice about those faces. Okay, so this cube has, what shape are its faces? Okay, the faces on this cube are squares. They have 4 equal sides and 4 right angles. Okay, now tell me how many faces are on this cube? So we can count 1, 2, 3, 4. There are 4 faces around the side, and then there is 1 on top and 1 on the bottom. So 4 plus 2 is 6. So our square has 6 faces. Our cube has 6 faces. Okay, in your collection of solids, which I'm going to put all of mine on my board. So we want to know what other solid has 6 faces. I'm just going to rotate them so you can see them. What other solid has 6 faces? Okay, so if you look, this solid also has 6 faces because we have 2 on each end, 1, 2, and then 1, 2, 3, 4. 4 long ones. Does anyone know what this solid is called? This solid is a rectangular prism. So we have a cube and a rectangular prism. This solid has 6 faces, but 4 of them are rectangular and 2 of them are square. So it's a little bit different. So it's called a rectangular prism because it has rectangular faces. Okay, so let's see, cube. our cube, and then rectangular prism. Okay. Look at your collection of solids again. Which of your solids has no faces? Which of our solids has no faces? So remember, a face is a flat surface on our solid figure. Okay, so this ball has no faces because it has no flat surfaces. It's just like a regular ball. What is the name of this shape? This shape is a sphere. S-P-H-E-R-E, a sphere. And a sphere has 0 faces. It has no flat surfaces. Okay, look at your shapes and figure out which one only has 1 face. This shape right here only has 1 face. What does this shape look like? I think this shape looks like a party hat, personally. You might think that it looks like an ice cream cone. And this shape is called a cone. Our cone has 1 face, and that face is a circle. What is a solid that has only 2 faces? So we've covered these 4 already. We know our sphere has none, our cone has 1, our rectangular prism and our square both have 6. So we have these 2 left. Which one has only 2 faces? So this shape has a lot of flat sides. So that one does not have only 2. However, this shape right here has 1, 2 circular flat pieces, and then a piece around. So this shape kind of looks like a can. And this shape is called a cylinder. So I'm going to write down, we have a cone, and then we have a, that's right. Oh, it's ER. ER, cylinder. Okay. And then finally, look for a solid that has an odd number of faces greater than 1. This shape, this solid, has an odd number of faces. How is it similar to some of the other shapes that we have in our collection? Well, I noticed that this shape has a point like our cone. It's a similar shape, except for it has flat sides. It also has no curved sides, similar to our cube and our rectangular prism. This shape is called a square pyramid, and it is called a square pyramid because the bottom, the base, is square. So our last shape is a square pyramid. So our cone has 1 face. Our cylinder has 2 faces. Our rectangular prism has 6. And then our square pyramid has 1, 2, 3, 4, 5 faces. Okay, look at your cube. Take out your cube. Put your hands on 2 faces of the cube that are close to each other. Now notice where they meet together. They meet together at this line. This line right here is called an edge. An edge is where two faces meet. What other shapes have edges? Well, I notice my rectangular prism has edges because we have two faces meeting at different points. And my square pyramid has edges because we have some faces meeting together. Okay. My cylinder does not have any faces that meet because the faces are on opposite sides. So our cylinder, does it have any edges? No. Our sphere definitely doesn't have any edges because it doesn't have any faces. And our cone only has one face, so it doesn't have any edges either. Okay, so with our geometric solids, we have places where 3 or more edges meet together. So if I'm looking at my edges on my cube, I have 1, 2, 3. So this is the point where 3 of our edges meet together. This point is called a vertex. Our vertex is where 3 or more edges meet together. Okay, so here we have a bunch of multiple vertex. If you have more than one vertex, it's called a vertice. Vertices. Okay, multiple would be vertices. Okay, I'm going to write those two words down. Vertex and okay, so you might recall these two words from when we were doing two-dimensional shapes or figures, because where two rays meet to form an angle, that point is also called a vertex. But in a 3D shape, you have to have 3 edges to meet at a point to create a vertex. Okay, pick up another solid, pick up another one of your solids and count how many vertices there are on your solid. I'm going to do the cube. Okay, so we're going to count the vertices of our cube. 1, 2, 3, 4, 5, 6, 7, 8. So our cube has 8 vertices. Our rectangular prism, we can assume, has the same because it has the same number of faces. Since our square pyramid meets at a point, that would be a vertex because 3 or more. This one has 4 edges meeting together. Okay, so we have 1, 2, 3, 4, 5 for our square pyramid. Okay, our cylinder and our cone don't have any vertices because they don't have any edges. And of course, our sphere has also no edges and no vertices. Okay, the next section we're going to do is we're going to look at characteristics of our specific solid figures. Okay, so we're going to look at more specific characteristics. So we looked at edges, faces, and vertices. So now we're going to specifically look at how our edges are related. Okay, so this cube has all of its vertices are labeled. Okay, so we're looking at different line segments within our cube. Okay, so we have a line segment CD here, GH here. Then we have line segments going this way, EG. All of the dotted line segments are the ones that would be on the opposite side of the cube that you could not see. So if we were looking at it like, let's see, like this, okay, E would be the edge back here. And then, or EF, and then FH would be this side, and then FB would be this side. Okay, so look at this cube. All of the faces we've already talked about are square, and we know because there are 4 equal sides and 4 right angles. Okay, what I want you to do right now is identify pairs of parallel lines in this cube. So immediately looking at this cube, I notice that line CD is parallel to line GH. And CG is parallel to DH. But another one could be AB and EF. I'm going to put 3 arrows there. Okay, and then also AC and BD. How do you know these edges are parallel? I know they're parallel because they have the same distance from each corresponding point. Okay, now I want you to find three perpendicular edges. 3 edges that are perpendicular. Okay, my first one I found was CG is perpendicular to GH. Those 2 edges form right angles. Another one that's not quite as obvious is AE and EG. So this right here forms a right angle. However, this angle, when you're looking at this picture, looks like it is obtuse. But if we were looking at the shape, let's see, like this, so AE is right here and EG is right here. And if I turn my cube, then we know that is a perpendicular edge, or these 2 edges are perpendicular. Okay. Another one, which also looks obtuse in this picture. Actually, let's do one that looks acute in this picture. One that looks acute in this picture, AC and AB, are also perpendicular for the same reason. It might look acute to you here, actually, like this. So these 2 lines might look acute to you because we've taken a 3D shape and made it 2D, but when you turn it, AC, AB, right here, right angle. Awesome job. Okay, so we're gonna look now at places where 3 line segments intersect. Okay, so I see AC intersects with CG, and that also intersects with CD. So these are all intersecting. Intersecting line segments. And the point of intersection is called our vertex.